All of us know what a number line is, and the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6, or -7 by 12. Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers, but we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p by q, one number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. It is a number of the form p by q, where p and q are integers and q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the two.
Properties of rational numbers. We have already learnt about rational numbers. What are they? Numbers of the form p upon q are known as rational numbers. There are certain conditions that p and q must follow. P and q must be integers. Q cannot be equal to 0. Properties of rational numbers. It has a numerator and a denominator. The numerator and denominator are integers. The denominator is not 0. All integers and fractions are rational numbers. 0 is a rational number. Rational numbers can be positive or negative. We are now going to look at more properties of rational numbers. We are going to see how they behave in different situations. There are mathematical words to describe these situations. The ones we will be discussing now are closure, commutativity, associativity, the role of 0, the role of 1, negatives, reciprocals, and distributivity. Are you alarmed looking at these words? Are your eyes open wide wondering how you're going to do all this in one shot? And do so much more mathematics for the rest of the year? Don't be. Though the words may sound unfamiliar, you actually know every single thing already. You just didn't know it was called that. It's really simple and you'll finish this in no time. Just stay alert and let's start. Properties of rational numbers. Closure. What does closure mean? Closure in the simplest forms means what kind of an answer you get when you add, subtract, multiply, or divide two numbers of the same kind. If your answer is the same kind as the kind of numbers, then you say that the type of numbers are closed. Otherwise, you say they are not closed. What does closure mean? These explanations in mathematics always seem complicated, don't they? But the examples always make it so easy. So let's just talk about the real thing now, shall we? Whole numbers are numbers from 0 onwards. Let's check closure for whole numbers under addition. What happens when you add two whole numbers? 7 plus 14 is 21. The answer is a whole number. 6 plus 0 is equal to 6. The answer is a whole number. You can add any two whole numbers. The answer will always be a whole number. So the whole numbers are closed under addition. That just means when whole numbers are added, the answer is always a whole number. Let's check closure for whole numbers under subtraction. What happens when you subtract two whole numbers? 14 minus 12 is equal to 2. The answer is a whole number. 14 minus 18 is equal to minus 4. The answer is not a whole number. When you subtract one whole number from the other, the answer may not always be a whole number. So whole numbers are not closed under subtraction. Do you understand what closed and not closed means now? Let's check closure for whole numbers under multiplication. What happens when you multiply two whole numbers? 7 multiplied by 5 is equal to 35. The answer is a whole number. 7 multiplied by 0 is equal to 0. The answer is a whole number. When you multiply two whole numbers, the answer is always a whole number. So, the whole numbers are closed under multiplication. That just means when the whole numbers are multiplied, the answer is always a whole number. Let's check closure for whole numbers under division. What happens when you divide two whole numbers? 16 divided by 4 is equal to 4. The answer is a whole number. 16 divided by 5 is equal to 16 upon 5. The answer is not a whole number. When you divide one whole number by another, the answer may not always be a whole number. So, the whole numbers are not closed under division. That just means when the whole numbers are divided, the answer is not always a whole number. Closure for integers. Integers are like whole numbers, but they also include negative numbers. Let's check for closure under all four operations for integers now. Let's check closure for integers under addition. What happens when you add two integers? 7 plus minus 14 is equal to minus 7. The answer is an integer. Minus 6 plus 0 is equal to minus 6. The answer is an integer. You can add any two integers, the answer will always be an integer. So the integers are closed under addition. Let's check closure for integers under subtraction. What happens when you subtract two integers? 7 minus 14 is equal to 21. The answer is an integer. 0 minus 12 is equal to minus 12. The answer is an integer. You can subtract any two integers, the answer will always be an integer. So, the integers are closed under subtraction. Let's check closure for integers under multiplication. What happens when you multiply two integers? 7 multiplied by minus 4 is equal to minus 28. The answer is an integer. Minus 2 multiplied by minus 4 is equal to 8. The answer is an integer. You can multiply any two integers, the answer will always be an integer. So, the integers are closed under multiplication. Let's check closure for integers under division. What happens when you divide two integers? 16 divided by minus 4 is equal to minus 4. The answer is an integer. Minus 12 divided by 5 is equal to minus 12 upon 5. the answer is not an integer. When you divide one integer by another, the answer may not always be an integer. So, the integers are not closed under division. Check closure under all four operations for rational numbers now. What happens when you add two rational numbers? 4 upon minus 9 plus 3 upon 4 is equal to minus 4 upon 9 plus 3 upon 4 is equal to minus 4 multiplied by 4 upon 9 multiplied by 4 plus 3 multiplied by 9 upon 4 multiplied by 9 is equal to minus 16 upon 36 plus 27 upon 36 is equal to minus 16 plus 27 upon 36 is equal to 11 upon 36. Minus 3 upon minus 5 plus 1 upon minus 2 is equal to 3 upon 5 plus minus 1 upon 2 is equal to 3 multiplied by 2 upon 5 multiplied by 2 plus minus 1 multiplied by 5 upon 2 multiplied by 5 is equal to 6 plus minus 5 upon 10 is equal to 1 upon 10. The answer is always a rational number, so rational numbers are closed under addition. What about the difference of two rational numbers? 3 upon 4 minus 7 upon 8 is equal to 6 minus 7 upon 8 is equal to minus 1 upon 8, which is a rational number. 5 upon 6 minus 2 upon 3 is equal to 5 minus 4 upon 6 is equal to 1 upon 6, which is a rational number. 8 upon 4 minus 2 upon 5 is equal to 40 minus 8 upon 20 is equal to 32 upon 20, which is a rational number. The answer is always a rational number, so rational numbers are closed under subtraction. What about the product of two rational numbers? The product of two rational numbers is the product of the numerators divided by the product of the denominators. A upon B multiplied by C upon D is equal to A multiplied by C upon B multiplied by D is equal to AC upon BD, where B is not equal to 0 and D is not equal to 0. As you can see, the product of two rational numbers is also a rational number. So, rational numbers are closed under multiplication. What about the division of two rational numbers? Division is the inverse of multiplication. Dividing means multiplication with reciprocal. A upon B divided by C upon D is equal to A upon B multiplied by D upon C, where B is not equal to 0 and D is not equal to 0. As you can see, division can be expressed as a multiplication. A upon B divided by C upon D is equal to A upon B multiplied by D upon C, where B is not equal to 0 and D is not equal to 0. Now, the tricky thing here is we know that B and D cannot be 0, but A and C can be 0. If A is 0, it doesn't matter. The answer will still be a rational number. If C is 0, then the answer will not be a rational number. So, the answer of a division of two rational numbers will not always give you a rational number. Hence, we can say that the rational numbers are not closed under division. Did you understand the closure property? Yes. Rational numbers. Properties of rational numbers. Closure, commutativity, associativity, the role of 0, the role of 1, negatives, reciprocals, distributivity. So, we've understood what closure is. Now, let's see what commutativity is. Commutativity checks whether the order of the numbers in the operation is important. Let's check commutativity for whole numbers. Let's check for addition. 4 plus 3 is equal to 7. 3 plus 4 is equal to 7. 0 plus 6 is equal to 6. 6 plus 0 is equal to 6. So, the order of the numbers does not matter. For any two whole numbers a and b, a plus b is equal to b plus a. So, addition is commutative. Let's check for subtraction. 4 minus 3 is equal to 1. 3 minus 4 is equal to minus 1. 6 minus 0 is equal to 6. 0 minus 6 is equal to minus 6. So, when the order of numbers changes, the answer changes. Hence, subtraction is not commutative. Now let's check for multiplication. 4 multiplied by 3 is equal to 12. 3 multiplied by 4 is equal to 12. 6 multiplied by 0 is equal to 0. 0 multiplied by 6 is equal to 0. Here too, you can see that with any two whole numbers a and b, a multiplied by b is equal to b multiplied by a. So, multiplication is commutative. Now let's check for division. 16 divided by 4 is equal to 4. 4 divided by 16 is equal to 4 upon 16. So, when the order of numbers changes, the answer changes. Hence, division is not commutative. In the same way, you can check commutativity for integers. Addition is commutative. Subtraction is not commutative. Multiplication is commutative and division is not commutative. Let's now check this property for rational numbers. The sum of two rational numbers remains the same no matter in what order they are added. 2 upon 7 plus 4 upon 7 is equal to 6 upon 7. 4 upon 7 plus 2 upon 7 is also equal to 6 upon 7. 9 upon 15 plus 2 upon 15 is equal to 11 upon 15. 2 upon 15 plus 9 upon 15 is also equal to 11 upon 15. So, addition is commutative. If a and b are two rational numbers, a minus b is not equal to b minus a. 3 upon 4 minus 7 upon 8 is equal to 6 minus 7 upon 8 is equal to minus 1 upon 8. Whereas 7 upon 8 minus 3 upon 4 is equal to 7 minus 6 upon 8 is equal to 1 upon 8. Minus 1 upon 8 is not equal to 1 upon 8. Let's take another example. 2 upon 3 minus 5 upon 6 is equal to 4 minus 5 upon 6 is equal to minus 1 upon 6. Whereas 5 upon 6 minus 2 upon 3 is equal to 5 minus 4 upon 6, which is equal to 1 upon 6. Minus 1 upon 6 is not equal to 1 upon 6. So, subtraction is not commutative. Now let's multiply 3 upon 7 and 5 upon 9. 3 upon 7 multiplied by 5 upon 9 is equal to 3 multiplied by 5 upon 7 multiplied by 9 is equal to 15 upon 63. Whereas 5 upon 9 multiplied by 3 upon 7 is equal to 5 multiplied by 3 upon 9 multiplied by 7, which is also equal to 15 upon 63. It doesn't matter what order the numbers are multiplied in, the product remains the same. So, multiplication is commutative. Now let's check commutativity for division. 8 upon 14 divided by 4 upon 2 is equal to 8 upon 14 multiplied by 2 upon 4 is equal to 2 upon 7. Whereas 4 upon 2 divided by 8 upon 14 is equal to 4 upon 2 multiplied by 14 upon 8 is equal to 7 upon 2. When the order of numbers changes, the answer changes too. So, division is not commutative. So we've understood what commutativity is. Now let's see what associativity is. Associativity is like commutativity, but for 3 numbers. Let's check it out. Let's check associativity for whole numbers for the addition operation. Is 5 plus 4 into brackets plus 3 equal to 5 plus 4 plus 3 into brackets? Yes, no matter which 2 numbers you add first, the answer does not change. So, addition is associative. Now let's check associativity for whole numbers for the subtraction operation. Is 10 minus 3 into brackets minus 2 equal to 10 minus 3 minus 2 into brackets? 10 minus 3 into brackets minus 2 is equal to 7 minus 2 is equal to 5. Whereas 10 minus 3 minus 2 into brackets is equal to 10 minus 1, which is equal to 9. Both the expressions are not equal. So, what you do first matters. So, subtraction is not associative. Let's check associativity for whole numbers for the multiplication operation. Is 5 multiplied by 4 into brackets multiplied by 3 equal to 5 multiplied by 4 multiplied by 3 into brackets? Yes, no matter which 2 numbers you multiply first, the answer does not change. So, multiplication is associative. Now let's check associativity for whole numbers for the division operation. Is 32 divided by 8 into brackets divided by 2 equal to 32 divided by 8 divided by 2 into brackets? 32 divided by 8 into brackets divided by 2 is equal to 4 divided by 2, which is equal to 2. Whereas 32 divided by 8 divided by 2 into brackets is equal to 32 divided by 4, which is equal to 8. Both the expressions are not equal. So, what you do first matters. So, division is not associative. Let's check associativity for integers for addition operation. Is minus 2 plus 3 into brackets plus minus 4 equal to minus 2 plus 3 plus minus 4 into brackets? Minus 2 plus 3 into brackets plus minus 4 is equal to 1 minus 4 is equal to minus 3. And minus 2 plus 3 plus minus 4 into brackets is equal to minus 2 minus 1, which is equal to minus 3. Both the expressions are equal. So, addition is associative. Let's check associativity for integers for subtraction operation. Minus 2 minus 3 into brackets minus minus 4 is equal to minus 2 minus 3 minus minus 4 into brackets. Minus 2 minus 3 into brackets minus minus 4 is equal to minus 5 plus 4 is equal to minus 1. Whereas minus 2 minus 3 minus minus 4 into brackets is equal to minus 2 minus 7, which is equal to minus 9. Both the expressions are not equal. So, what you do first matters. So, subtraction is not associative. Let's check associativity for integers for multiplication operation. Is minus 2 multiplied by 3 into brackets multiplied by minus 4 equal to minus 2 multiplied by 3 multiplied by minus 4 into brackets? Minus 2 multiplied by 3 into brackets multiplied by minus 4 is equal to minus 6 multiplied by minus 4, which is equal to 24. And minus 2 multiplied by 3 multiplied by minus 4 into brackets is equal to minus 2 multiplied by minus 12 is equal to 24. Both the expressions are equal. So, multiplication is associative. Let's check associativity for integers for division operation. Is minus 54 divided by 9 into brackets divided by minus 3 equal to minus 54 divided by 9 divided by minus 3 into brackets? Let's take a look. Minus 54 divided by 9 into brackets divided by minus 3 is equal to minus 6 divided by minus 3 is equal to 2. Whereas minus 54 divided by 9 divided by minus 3 into brackets is equal to minus 54 divided by minus 3 is equal to 18. Both the expressions are not equal. So, what you do first matters. So, division is not associative. Let's check associativity for rational numbers. When adding more than two rational numbers, it doesn't matter which two numbers we group at a time. Let's take a look. 2 upon 7 plus 3 upon 7 into brackets plus 1 upon 7 is equal to 5 upon 7 plus 1 upon 7 is equal to 6 upon 7. And 3 upon 7 plus 1 upon 7 into brackets plus 2 upon 7 is equal to 4 upon 7 plus 2 upon 7 is equal to 6 upon 7. So, addition is associative. We can write it like this. A upon B plus C upon D into brackets plus E upon F is equal to A upon B plus C upon D plus E upon F into brackets, where B is not equal to 0, D is not equal to 0 and F is not equal to 0. So, addition is associative. The product of three rational numbers is the same even if the order of grouping of the numbers is changed. A upon B multiplied by C upon D into brackets multiplied by E upon F is equal to A upon B multiplied by C upon D multiplied by E upon F into brackets, where B is not equal to 0, D is not equal to 0 and F is not equal to 0. You can easily verify this. 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 is equal to 2 upon 3 multiplied by 4 upon 5 into brackets multiplied by 2 upon 7 is equal to 8 upon 15 multiplied by 2 upon 7 is equal to 16 upon 105. And 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 is equal to 2 upon 3 multiplied by 4 upon 5 multiplied by 2 upon 7 into brackets is equal to 2 upon 3 multiplied by 8 upon 35 is equal to 16 upon 105. So, multiplication is associative. Subtraction is not associative for rational numbers. Let's check. Is minus 2 upon 3 minus 4 upon 5 minus 1 upon 2 into brackets equal to minus 2 upon 3 minus 4 upon 5 into brackets minus 1 upon 2? Let's take a look. Minus 2 upon 3 minus 4 upon 5 minus 1 upon 2 into brackets is equal to minus 2 upon 3 plus 13 upon 10, which is equal to 19 upon 30. Whereas minus 2 upon 3 minus 4 upon 5 into brackets minus 1 upon 2 is equal to 2 upon 15 minus 1 upon 2, which is equal to minus 11 upon 30. So, subtraction is not associative. Division also is not associative for rational numbers. Let's take a look. Is 1 upon 2 divided by minus 1 upon 3 divided by 2 upon 5 into brackets equal to 1 upon 2 divided by minus 1 upon 3 into brackets divided by 2 upon 5? Let's take a look. 1 upon 2 divided by minus 1 upon 3 divided by 2 upon 5 into brackets is equal to 1 upon 2 divided by minus 1 upon 3 multiplied by 5 upon 2 into brackets is equal to 1 upon 2 divided by minus 5 upon 6 is equal to 1 upon 2 multiplied by minus 6 upon 5, which is equal to minus 6 upon 10. Whereas 1 upon 2 divided by minus 1 upon 3 into brackets divided by 2 upon 5 is equal to 1 upon 2 multiplied by 3 upon minus 1 into brackets divided by 2 upon 5, which is equal to minus 3 upon 2 divided by 2 upon 5, which is equal to minus 3 upon 2 multiplied by 5 upon 2 is equal to minus 15 upon 4. So, division is not associative. Did you understand the associative property? Yes. We've understood what is closure property, commutativity, and associativity of the rational numbers. Now, we'll be looking at the role of 0. What happens when you add 0 to a number? Let's check for whole numbers, integers, and rational numbers. Add 0 to a whole number. 4 plus 0 is equal to 4. 0 plus 96 is equal to 96. The number remains the same. Add 0 to an integer. Minus 4 plus 0 is equal to minus 4. 0 plus minus 6 is equal to minus 6. The number remains the same. The sum of a rational number and 0 is the same rational number itself. 0 plus 6 upon 13 is equal to 6 upon 13. 4 upon 7 plus 0 is equal to 4 upon 7. 0 plus 5 upon 9 is equal to 5 upon 9. 6 upon 11 plus 0 is equal to 6 upon 11. 0 plus a upon b is equal to a upon b, where b is not equal to 0. Therefore, 0 is called the identity for the addition of rational numbers. That means when you add it to a rational number, the rational number remains unchanged. The product of a rational number and 0 is 0. A upon b multiplied by 0 is equal to 0, where b is not equal to 0. You can easily verify this. Minus 5 upon 9 multiplied by 0 is equal to 0. 0 multiplied by 8 upon 7 is equal to 0. 3 upon minus 11 multiplied by 0 is equal to 0. So, we've understood what the role of 0 is. Now, we'll be looking at the role of 1. Let's check for rational numbers and find out. The product of a rational number and 1 is the same rational number. You can easily verify this. Minus 5 upon 9 multiplied by 1 is equal to minus 5 upon 9. 1 multiplied by 8 upon 7 is equal to 8 upon 7. 3 upon minus 11 multiplied by 1 is equal to 3 upon minus 11. The product of a rational number and 1 is the same rational number. That means a upon b multiplied by 1 is equal to a upon b, where b is not equal to 0. 1 is called the multiplicative identity for rational numbers. That is because when we multiply a rational number by 1, we get the same rational number. So, we've understood what the role of 1 is. Let's check out the negative of a number. You know what the negative of an integer is. The negative of 3 is minus 3. The negative of minus 4 is 4. It's basically the additive inverse. When we add an integer to its negative, we get 0. Rational numbers have negatives too. When we add a rational number to its negative, we get 0. So, the negative is also called the additive inverse. Rational number 11 upon 36. The additive inverse is minus 11 upon 36. Rational number minus 7 upon 12. Its additive inverse is 7 upon 12. Rational number 6 upon 13. Its additive inverse is minus 6 upon 13. So we've understood what the negative is. Let's check out the reciprocal of a number. Rational numbers have reciprocal. If a upon b multiplied by c upon d is equal to 1, then c upon d is the reciprocal of a upon b. You can easily find the reciprocal of a rational number by flipping the numerator and denominator. Remember, 0 has no reciprocal because 0 cannot be in the denominator of a rational number. Find the reciprocals of these rational numbers. 4 upon 7 gives us 7 upon 4. Minus 3 upon 4 will be minus 4 upon 3. Minus 2 upon minus 9 will be 9 upon 2. 1 upon 7 will be 7 upon 1 is equal to 7. 12 upon 19 will be 19 upon 12. 13 will be 1 upon 13. Answer these questions. The reciprocal of a rational number is a rational number. Does 0 have a reciprocal? No. What is the reciprocal of 1? 1. What is the reciprocal of minus 1? Minus 1. Is the reciprocal of a negative rational number also negative? Yes. A reciprocal is also called the multiplicative inverse. Why is that so? Because when we divide a rational number by the other, we take the reciprocal of the divisor and convert the division to multiplication. So, we can take the inverse to multiply. That inverse is the reciprocal and the use of it is multiplication. Hence, reciprocal is equal to multiplicative inverse. Get it? When we divide a rational number by 1, we get the same rational number. 8 upon 14 divided by 1 is equal to 8 upon 14. Minus 16 upon 70 divided by 1 is equal to minus 16 upon 70. When we divide 1 by a rational number, we get the reciprocal of the rational number. 1 divided by minus 6 upon 20 is equal to minus 20 upon 6. 1 divided by minus 16 upon 9 is equal to minus 9 upon 16. What's additive inverse? It's the negative of a number. What's multiplicative inverse? It's the reciprocal of a number. When you add a number to its additive inverse, you get the answer as 0. When you multiply a number with its multiplicative inverse, you get the answer as 1. Remember that properly without getting confused. Kidding, of course you won't, you're smart. So, we've understood negatives and reciprocals. Let's check out the negative of a number. Let's check out the last property, distributivity. Distributivity is actually distributivity of multiplication over addition. It's easy to understand by just looking at it directly rather than just explaining in theory. Well, most of mathematics is that way. You just have to get it properly. Then it's all easy breezy. Look at this expression. We have a bracket, so we solve that first. Then we multiply and get the value. 5 upon 7 plus 6 upon 15 into bracket multiplied by 2 upon 5 is equal to 75 plus 42 upon 105 into bracket multiplied by 2 upon 5 is equal to 117 upon 105 multiplied by 2 upon 5 is equal to 78 upon 175. Now look at this expression. We do the multiplication first and then the addition, and we get the same value. 5 upon 7 multiplied by 2 upon 5 plus 6 upon 15 multiplied by 2 upon 5 is equal to 2 upon 7 plus 4 upon 25 is equal to 50 plus 28 upon 175 is equal to 78 upon 175. Interesting. Let's get to the bottom of this. This is something that is going to help you a lot in mathematics that you'll do for years to come. We just found out that these two expressions mean the exact same thing. Basically, what has happened here is that when we open the bracket, that multiplying factor outside the bracket goes to each term inside the bracket. What if we had a subtraction inside the bracket instead of addition? Doesn't matter, it would still work. 5 upon 7 minus 6 upon 15 into brackets multiplied by 2 upon 5 is equal to 5 upon 7 multiplied by 2 upon 5 minus 6 upon 15 multiplied by 2 upon 5. Now, you may wonder, does this hold true for multiplication? Well, we know that whatever is multiplied to the bracket applies to each term inside the bracket. So, is this true? 4 upon 5 multiplied by 3 upon 7 into brackets multiplied by 2 upon 3 is equal to 4 upon 5 multiplied by 2 upon 3 into brackets multiplied by 3 upon 7 multiplied by 2 upon 3 into brackets? No! We said each term inside the bracket. Inside the bracket, we have 4 upon 5 multiplied by 3 upon 7. This is one term. Terms can be separated by addition or subtraction only. If there are numbers separated by multiplication or division, they are still one term. This is the mathematician's way of showing distributivity of multiplication over addition for rational numbers. A upon B plus C upon D into brackets multiplied by E upon F is equal to A upon B multiplied by E upon F plus C upon D multiplied by E upon F, where B is not equal to 0, D is not equal to 0, and F is not equal to 0. Did you understand the different properties of rational numbers? Yes.